Okay, so in this video, we will talk about measures of variation. So first of all, range. So what's the definition of range? So the range is the difference between the maximum value and the minimum value of the data set. So if you take a look in here, consider that's the set of the quiz score. What is the maximum? Well, should be maximum would be 29. So we have the maximum. No, it's 14.5. Oh my god. It's 14.5. So now let's find the minimum. Minimum 12. Is any number less than 12? Nope. So this is our minimum, 12. So the range is equals to the maximum subtract the minimum. So the range of this quiz score would be 13.3. That's really big gap in here. Okay, so definition of standard deviation. So the standard deviation is a measure of variation based on the measured distance each eta value deviates or in difference from the mean. A few important characteristics is standard deviation is always positive, and the standard deviation would be 0 if all the data values are equal, because that makes sense. If they're all equal, that means they're all equal to mean. Variation is trying to measure how far away from each data from mean. So since you're equal, that means the distance would be 0. That's why the standard deviation would be 0. And it will get larger as the data more spread out. Also, standard deviation has the same unit as original data. Standard deviation, like mean, can be highly influenced by the outliers. So here's the way that we do standard deviation computation. I'm going to show you in here. So now you have a data set. So the first step is after the data, you need to find out the mean of this data. We totally have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first step is you find out about mean. Remember how to do mean? Mean is you add all the data together and divide it by the number of data. I forgot, I just counted. Totally 10 data. You divide it by 10. So the mean is equals to 5. So the deviation is each data you subtracted by mean. So I have a 0 subtracted by mean, which is equal to 5. 5 minus 5, 0. 5 minus 5, 0. Since this is all 5, so the deviation would be all 0. And then the last one is you use the data value, subtract the mean, also equals to 5. So remember, this is negative 5, sorry. So remember, this is called deviation. So after that, we need to square the deviation. So we have negative 5 squared, which is equal to positive 25, and then 0 squared equals to 0. So these are all 0. And now when it comes to this one, the deviation of the last data set is 5 squared, which is 25. Okay, after you find the square deviation, the next thing to do is you find the sum of the square of the deviation. So the sum of it would be what? 25. 25 at 0, there's a 0. And then add another 25. Oh, here's 25. So the sum of the square deviation equals to 50. So, okay, how do you find the popular variance? So the popular variance is you have 10 data set, right? So you use the sum of the square deviation. you square them, and then divide it by the number of data, which is divided by 10. So in this case, we have 15 divided by 10, which is equal to 5. But for sample variance, it's a little bit tricky. The sample variance is we don't divide it by 10. We divide it by the number of data sets subtract by 1. So like say, this data set equals to 10. So I should say here is divided by the number of data set, but for sample variance is after you get the sum, you divide it by n minus 1. So you have 15 divided by 9. So I have 5.56. Okay, so that's the difference. Popular variance is you divided the whole data set. The sample variance is you divided the number of data sets subtract by 1. Okay, so now what is the population standard deviation? So the population standard deviation is you take square root of the variance. So in our case is 15 divided by 10, which is square root of 5. So I have approximately 2.2. So the sample standard deviation is the same. You take square root of the sample variance, which is 50 divided by 9. So I have 5.56, and then approximately equals to 2.4. Okay, that's how you find the standard deviation. Okay, next part is quartile. So quartile are the value that divide the data into quartile. So the first quartile is the value, so that 25% of the value are below it. And the third quartile is the value, so that 75% of the data are below it. You might have guessed the second quartile is the same as median because that's what you have. The 15% of value are below it. So this divides the data into the quartile of 25% of data, and then 25% the data between minimum and the first quartile, and is between first quartile and the I'm not going to read this. So basically, you have a minimum, first quartile, medium, which is also a second quartile, third quartile, and the maximum. So you think about how does this data divided. So 15% of data below medium, right? And then first quartile would be 25%. And then third quartile will be 75% of the data. And then minimum would be what? Minimum would be, since your minimum, 0% of data below it. For maximum, how do you define maximum? Would be 100% of the data below that number. So this is also called Fine's number summary. So first of all, how do we find the first quartile? So the first quartile, remember that the first quartile means at that point 25% of the data going to be below the first quartile. So to find the locator, what we go do is you want to compute 25% of how many data do you have. That's the first step. And then the second step is you have a two part. If L is a decimal, that means it's not a whole number. So that means we want to round up the locator, L, and then use the data in L plus 1 location, the round up location. For example, if you find out that, hey, 6.25, you round up to 7, so that means the 7th data is going to be your first quartile. But if L is a whole number, what would you do? If it's whole number, so this is going to be the Lth data plus L plus 1th data and divided by 2, which is the middle between Lth and the L plus 1th data. For example, if you find out the locator is 8, so that means the first quartile is going to be 8th plus the 9th data divided by 2. I'm going to show you later. So, not finding, here should be third quartile. So the third quartile is similar, but the first step is going to be, since first quartile is 75% of data below that, so you should use 75 times how many data that you have. And then you need to discuss by case if L is a decimal or L is a whole number. So here is an example. Now let's try it. So this order is already ordered from the lowest to the highest. So now we will need to find our minimum, first quartile, medium, third quartile, and the maximum. So minimum and maximum, medium are easy. So minimum is 59, maximum is 72. Remember, you always need to order from the smallest to the largest. Okay, so since this is a 9 data, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, totally 9 data. So n, the size of the data, is equal to 9. Okay, so the medium should be the 5th one. So 66. So first quartile. So remember, we need to find the locator for the first quartile. L equals to 25% times 9. So we will know how many data are below 25%. So this is equals to, let me calculate that very quick. Okay, so the locator is equals to 2.25. Again, look at here. So since this is a decimal, not a whole number, so that means if it's decimal, we need to round up. Okay, so 2.25 you round up, so the locator should be third. So that means the third data is going to be our first quartile. Okay, now let's find Q2. Q3, sorry. Q3 is also equals to the locator, which is 0.75 of data times 9, which is equal to 6.75. Again, this is not a whole number, so that means we need to round up. So that means the 7th of the data is going to be our third quartile. So the 7th data would be 69. So that's it. That's the 5 number summary. Okay, so now we have 8. Let's try this again. So we have 8th data set, n is equals to 8, and we want to find the minimum, Q1, medium, Q3, and the maximum. Again, medium is also called Q2, which is 50% of the data below it. So now we need to find the minimum. Very easy. The first data is minimum. The last data is going to be maximum. Okay, to find Q1, we need to use A times 0.25 to find the locator. So 8 times 2.5 is 2. Okay, so this is a whole number. What are we going to do? If it's a whole number, we need to use that locator and then plus the next data and divide it by 2. So that means we want the second data plus the third data and divided by 2, which is find the median between these two. So this is the first and second data and then you add these up together and divide it by 2 is equals to 61. Okay, medium, we can use the same idea to find medium. So the second quartile should be the number of the data times 50%, which is 4. The idea should be the same, should be the 4th data at the 5th data and then divided by 2. So the 4th data is here. 4th data and 5th data would be 64 plus 66 over 2, which is 65. So medium would be 65. Q3, let me erase these. I am running out of room. So Q3 would be the size of the data set times 0.75, which is equals to 6. So it's a whole number. So that means it's going to be the 6th and 7th data, the mean between, or the average between the 6th and 7th data, which is 67 and 69. So it should be 68. So this is our third quartile. This is our 5-number summary. Okay, to visualize the data, there is a graphical representation of a 5-number summary called box plot. So a box plot is a graphical representation of a 5-number summary. So how do we do that? So let's choose the easiest one. So we know that, hey, this is just 5 numbers, so it would be easier to figure out. So this is our minimum, first quartile, medium, third quartile, and the maximum. So the number 9 is first to draw the equal distance stick mark. So the box is drawn from the first quartile to the third quartile, and the 9 is drawn through the box as the medium. So whiskers are extending out the minimum and the maximum. So in here, you will draw the first quartile in here, which means the left end of the box should be your first quartile, and the right end of your box should be your third quartile. And you also need to label the medium in here. And then you will have a whisker, which is outside of the box, would be your maximum and the minimum. That's how you draw a box plot. Oops. Okay, so now here is an example. Oops. So the box plots of service time for 2 fast food restaurants is shown below store 1 and store 2. The first graph is store 1, the second graph is store 2. So again, the first number in here would be the minimum, first quartile, medium, third quartile, and the maximum. For store 2 is the same. Outside the whisker on the left end is going to be your minimum. The left end of the box would be your first quartile, medium, third quartile, and the maximum. Okay, while store 2 has slightly shorter medium services time, store 2 is less consistent with a wider spread of the data because it's more spread out. And then at the store 1, 75% of customers were served within 2.9 minutes, which is our third quartile. With store 2, 75% of the customer was served within 5.7 minutes. When you see 75%, you should know that, hey, this is third quartile. Okay, which store should you go in a hurry? That depends upon your opinion about luck. 25% of the customers at store 2 had to wait between 5.7 to 9.6 minutes, which is in here because we know that from third quartile, the data is 17% to 100%. So that means in between them is 25%. Okay, so that's it for this chapter. I think it's really interesting to look into the data and how to visualize the data is really powerful. So I hope you enjoyed this class. Let me know if you have other questions.